Hey guys, just wanted to make you a quick video so you knew how to do these mixed stoichiometry problems. So I asked you for e-learning for the week of the 13th, and it includes the 13th, 14th, and 15th, to do these problems right here. And we haven't really looked at this page yet, but it is the stoichiometry mixed problems. So mixed just means in this sense that we are, where's my mole map? That we are going from any of the cities to any of the other cities on the mole map. So that's all mixed means. We're not doing anything different. We're just traveling to different cities, which we already learned quite a long time ago. So I wanted to do number 1 with you really quick, just so you knew what you were doing. Now, these problems are exactly like the problems we have been doing, just going to different cities. So in other words, all you have to do is follow the same steps. Just to give you something like a roadmap that's a little bit more general, I also wrote this on your e-learning instruction sheet. But for all of these problems, you are going to, we gotta pick a better color than red. Let's go with purple. Okay, so for all of these problems, you are going to still use the steps that I think are not on this slide. Oh, that's no good. Oh yeah, there's your steps. Okay, you're still going to use these steps, but your general pathway is the given. So identify the given, convert the given to moles, then you can use your mole ratio, and then you convert to whatever you are trying to find. So if we look at this first problem right here, it says, and just like always, I'm just using the steps that are located right up there. So step number 1 says, read the problem. So it says, what volume of NH3 at STP is produced if 25 grams of N2 is reacted with an excess of H2. Now, this whole reacted with an excess, whenever you start seeing this word excess, or sometimes they'll say unlimited amount, whenever you see excess, that stuff doesn't matter. You're only looking for what they're asking you for. So we're looking for the volume of NH3, and I'm double underlining it because I know I have to double underline what I'm trying to find. And step number 2 tells me to single underline the number. And that is always where I start, that single underlined thing. Now, if you look here, I am starting in grams, and I have to find volume. So I'm going to go 25.0 grams of N2, because that's given. I just underlined it one time. That is always where I start. Now, if I look up here, I go from the given to moles. When I do that, I use my mole map to do that. So let's check up here and see what we have to do. So to go from mass city, which is right here, to mole city, I have to use 1 mole over the molar mass. Okay, that's fine. I can do that. So I can say 1 mole of N2 for every, the molar mass of N2. Let's look down here at our handy periodic. Oh, look, there's nitrogen right there. So 14. So 14 times 2, because it's N2. Oh, that's no good. Okay, so 14 times 2, because it's N2, is 28 grams of N2. And then grams of N2 cancels out. Now we're in moles of N2. Now if we go up just a little bit, now we can use our mole ratio. Yay for us. That comes from the balanced chemical equation, which is given right here. Okay, so our balanced chemical equation given right there. Now we want units to cancel out diagonally. So when we're doing our mole ratio, moles of N2 has to go on the bottom, because see, moles of N2 and moles of N2. So we want those to cancel out. What we're trying to find, moles of what we're trying to find has to go on top. So moles of NH3, that's the thing we double underlined right there. Now we need to look at our balanced chemical equations. What are the coefficients in front? So we have 2 there, and up, understood, 1 here. So this is 1, and this is 2. Now, we used our mole ratio. Let's cancel out our units. Moles of N2 cancel out. Mole of N2, mole of N2, cancel, cancel. And now it says that we have to go from our mole ratio to the unit we're trying to find. So I look here and I remember that I double underlined volume. So I have to go from moles, which I'm in right here, to volume. So I'm going to look back up here and I'm going to say, how do I go from mole city to volume city? Well, right there's my conversion factor, 22.4 liters over 1 mole. I'm going to erase this stuff off of here so I don't forget, because I'm almost done with this video. It's going to be a short one. So let's go back down here and plug this in. So for every 1 mole of NH3, it's 22.4 liters of NH3. All right, so now we got to do some math. So we're going to multiply everything on the top divided by everything on the bottom. So on the top we have 25 times 2 times 22.4. I think I have a calculator open. I do. So all clear. 25 times, why did it say 22? 25 times 2 times 22.4. 25 times 2 times 22.4 equals 1,120. So over here, 1,120 divided by 28 times 1 times 1. So that's just 28. So divided by 28. Go back to my calculator. Divided by 28 equals, wow, 40. Who'd have thought? Okay, so I got 40. So my answer is 40 liters of NH3. Now I need to look at my conversion factor, or my starting number, and check my significant figures. My starting number was 25.0. That has 3 significant figures. So my answer has to have 3. So I need to go 40.0 liters of NH3 to get the correct answer. 40.0 liters of NH3. That is 3 significant figures, and that would be my answer. Okay, so I've done number 1 for you. Now you just have to do 2, 3. Actually, I think I'm going to circle them for you. Yeah, I will. So I'm going to need you to do 2, 3, 4, and 5, and 6 actually on your own. 6 is hiding. I will fix that right now by making this periodic table a little smaller, or maybe I will not. Let's see if I can fix that so I can show you that I need you to do that problem as well. Select your tool, move this over a little bit and down a little bit, and we should be good to go. We are. Okay, so 2, 3, 4, 5, 6. I need you guys to do on your own. If you need any help, please let me know by email, and please don't forget to do your quiz on Canvas. Thanks, guys.